Hi dear students. Today we are discussing about sets. First chapter of mathematics for 11th class or PU1 you can say. See, in this chapter we have very simple definitions and very simple examples, and that we are discussing very easily one by one. Okay. So now let us see what is set first. See, basically sets means if you say a group, a collection, you will say it as a set. But generally, a set cannot be considered mathematically as you say in general word. Why? Because whenever you want to say a given collection as a set, no, it must be a well defined. Now, so I say the definition. A set is well defined collection of objects or numbers, whatever it is there. Okay, remember it must be well defined set. A collection of English vowels is a set. Suppose you want to say that there is a group of people, those who are all of height more than 5 feet, that is a collection, is a set. And now remember, it's very important thing is that whenever you want to set, no, if anybody pick an element, easily it can be identified that it is belongs to a specific set only, specific group only. Then only we can say that it is a set. Otherwise, it cannot be a set. Okay, so that is very important. Okay, so now set is well defined collection of objects. See, generally sets are denoted by capital letters. How A, B, C and so on like this. And the elements of the set, members of the set, elements you can say, or else elements or members of the set, are given by small letters A, B, C and so on like this. Okay. Now let us what we do. I take an example. What is a set? One simple example. A set of English vowels. Correct? What is this? I say it is denoted by capital A, and members of this are A, E, I, O, U. So this is generally how we denote a set. Correct? Very good. Now I come back to this one. And there are two different types of sets are there. One is a finite, another one is infinite. So, finite set. What is a finite set? Whenever a set is having finite number of elements, then we can say it is a finite set. Whenever a set is having an infinite number of elements, it is called an infinite set. A set having finite number of elements. A set is having a finite number of elements is called a finite set. What is infinite? A set having infinite number of elements is called an infinite set. If you want to say the finite set example, I can give anything. Look at this. A equal to, I say 1, 2, 3, 4, 5. Only 1 to 5 natural numbers are now considered, so it is a finite set. And if I consider set of all English alphabets, that is a finite set. And the next one, for example here, set of integers, set of real numbers, set of natural numbers, they all belongs to the category of set of infinite sets. So remember, it is a very simple and very easy. Very easily you can remember what is finite. If you have elements finite, then set is finite. If you have elements infinite, then set is infinite. Okay? This is remember. And now the very important thing is that how to denote a set means representation of a set. Representation of a set. Representation of a set. Representation of a set. Okay, there are two different methods are there to represent a set. One is roster form. You can also say tabular form or tabular form. And second one is set builder form. This is also called by formula form, formula method. Okay, yes. Now let us see here what is a roster form or a tabular form. So first one I will take roster form. I will take roster form. Okay, what is a roster form? Whenever if you write all the elements as a list. See here, I have written 1, 2, 3, 4, 5 as a list. I have made completely the list. Here I have not made any list. So that representation we call it as roster form or tabular form. What is a tabular form? Here in this form we write all the elements. We make a list of all the elements. In this form, all the elements are listed. In this form, all the elements are listed. Remember, they made it as a table. Then we can call it as a roster form. For example, set A equal to, I may say here, multiple of three numbers, 3, 6, 9, 12, 15. It's in a form. This is called roster form. Here I have made just a list of the elements, then we can say it is roster form. My dear students, one more example I will take. Small a, b, c, d, so on, z. Do you think that it's not a roster form? No, it is a roster form. Here I have just made it as one simple way, that is called a general notation. But here it understood that the elements are present in E, B, E, F, G, H, all that kind. Okay. So for that it is also belongs to roster form. And the next one is set builder form. In the set builder form, generally what we do is we use a formula or else a common rule to represent the set. Second one, set builder. Set builder. Set builder form. Here we don't write elements, but instead of that what we do is we write elements in the formula form. See, look at this. It means that in this form of representation, all elements are given by a common rule. Now look at this. How to write this one? Say for example, I will take A equal to set of naturals less than 10. Suppose if I am interested to write what are the natural numbers which are less than 10, how to write it in the form of set builder? Simply I write it as x. X means any member, it is any element. Then I have to give a common rule. I have to say here x value is from 1 to 10 and x is a natural number. Oh, I am using so many here notations. Look at this. What is, take the half of this part. 1 is less than or equal to x. What is the meaning of this? X value equal to 1 or more than 1. X is greater than or equal here. So what is the meaning of this? It means that either x is 1 or more than 1. But here x is telling you that smaller than 10. If it is smaller than 10, can it be equal to 10? No. Why? Look at this. Here it is 1 equal to, I have written. Here there is no equality sign. So x value starts with 1 but it will ends with before 10. So for that there is no equality sign. And here I am using one e like symbol. It is called belongs to. It is belongs. It means that it is belongs to. Means x belongs to natural number. What is the x value? It is a natural number. 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 cannot be because x is not equal to 10 here. So very simple representation it is. But remember, my dear students, whenever they write like this, we must be able to understand the elements nature present in the given set. This is very important. Okay, so this is about the representation of a set and finite infinite set. See, one more definition I write here only, that is empty set. Empty set. EMPTY. Empty set or null set. This is what we call empty set or null set. What is the meaning of this empty set or null set? Whenever you have a set, if there is no single element, then what we call? It is an empty set. So a set having no elements. Don't say zero element, no elements. You can also say void set also. See the names. Empty set, null set, void set. For example, it is denoted by, pi. Generally, an empty set is given by pi. So, or you can say like this, open braces. There should not be any elements here, 0 or nothing. Okay, that means it is an empty set. Okay, this is what you have to understand very properly. And one more very important, I will write universal set. Universal set. What is universal set? See here. Universal set means a set consisting of all the elements. Arey Baba, all the elements means what? It is always depends on the nature of the problem. It always depends on the discussion. The discussion, if you are doing based on the natural number set will be universal set. The discussion, if you are doing only for the real numbers, all real number set will be the universal set. Okay, what is universal set? A set consisting of all the elements, then it is called universal set. universal set. Okay, so understand this very properly. Universal set means all the elements are present. Null set means no element is present. All, no, no, all. Both are opposite, both are complement. You can say complement of a null set is always universal set. Complement of universal set is always a null set. Understand? Very important. And Yore Baba, you always denote this set, null set, by pi. Then why cannot be me as a whole set? There should not be a representative. Yes, I have a representative. What is that? It is denoted by. It is denoted by U. Capital U always indicates that it is universal set. Yes, my dear students, I hope you understood what is a null set, what is universal set, and what is finite set, what is infinite set, and very simple definitions. These are all. Here one more definition I can add with this one. What is that? That is very simple. You can say equal sets. Equal sets. I can say equal sets. Equal sets. One more definition. Equal sets. What is the meaning of equal sets? Very simple. अगर हमारे पास दो सेट्स है, we are having two sets, then both the sets are having the same elements, then we say that equal sets. Same elements, then we say that equal sets. Yes, if the two sets are having exactly the same elements, then we say that equal sets. If two sets, suppose you can say A and B are having exactly same elements, then A and B are equal sets. A and B are equal sets. Say for example, I will take one example. A equal to A, E, I, O, U. I will take B, O, I, E, A, U. Look at this order. I didn't say anything else. This is, I think you know very well. Very good. If I am talking about the order, then you bother. I am not bothering about the order here. I said only the same number of elements. Yes, understood my point? What I am going to say? Yeah. A, E, I, O, U, O, I, E, A, U. All the five elements which are present in A, they are present in B. Obviously, you can see that A is equal to B. Yes, understood? It's very simple. If same elements are present in both the sets or any n number of sets, they are all equal sets. But my dear students, you must be aware of one very important thing. What is that? That is equivalent sets. ये क्या है? अरे equal set हो गया, अभी equivalent set. What is equivalent sets? Look at this. Equivalent sets. There are many students get confused about this. Equal and equivalent. अरे दोनों एक ही है? No. Both are not same. Why? Equivalent means same number of elements present. Equal means same elements only has to present. Don't understand, sir. See here, I have A, E, I, O. There are 5 elements. If I write 1, 2, 3, 4, 5 here also 5 elements. Number of elements in both the sets are same. So we can say that both are equivalent sets, not equal sets. Understood my point? Yes. Now let's read the definition. If two sets are having equal number of elements, of elements, then both the sets are said to be equivalent. Yes. Now I will take an example. Say A equal to A, E, I, O, U. B I will take A, B, C, D, E. A, B, C, D, E. Do we have B here? No. Do we have C here? D here? No. Only two elements A and D are same. But both are not equal because all the elements must be same. Then only we say that equal sets. Now they are not equal. Yes. Now we understood very properly. So two sets are not equal. That is fine. I say number of elements n of A. How many? 5. Number of elements in A are 5. Number of elements in B, they are also 5. Number of A, number of B same, they are equivalent. Therefore, number of A is same as number of B. Therefore, we can say that these two sets are equivalent sets. Yes, very good. Here, Sif, only what we concentrate is how many elements present in both. If both the numbers are equal, they are equivalent. If both the elements are same, then they are equal. Yes? Yeah. Tomorrow, in the next class, we are discussing about the problems or exercise. Thank you. And also, I forgot to tell you one more thing. If you want to see all the continuous, all chapter videos, subscribe the channel, Sai Spurti channel, Sai Spurti Online Academy. You will get all the videos of competitive exams. Also, you will get complete competitive examination information also, and also very important thing, this your textbook syllabus with exercise. Okay? Yes, all the best.